Okay, cool. So we're going to continue the multiple choice. We are given the graph of function f shown in the figure where there's a vertical tangent at the point 2, 0. So 2, 0, that means there's a vertical tangent here. And the horizontal tangent at the point 1, negative 1. Oh, cool. And 3, 1. For what values of x from negative 2 to 4 is f not differentiable? So we know that we definitely cannot differentiate here and definitely cannot differentiate here because we have a lack of continuity here and we have a vertical asymptote there. So that just leaves us with B. So your answer is going to be B. I find for these problems to just ignore the answers and do the problem and then find what matches your work. All right. For 14, a particle moves along the x-axis here. For what value of t is the velocity of the particle 0? So we have our position here. Our velocity is equal to the derivative of position, which in this case is 2t minus 6. And when it's equal to 0, we solve t equals 3. Cool. All right. So we know that f of x is equal to this integral from 0 to x of the root t cubed plus 1 dt. F prime of 2 is going to be root x squared plus 1 at 2, which is going to be square root of 9, which is in fact 3. Cool. I put parentheses around there to indicate that this is our function and this is what we're evaluating at. Okay, 16. Let me make sure you can see that. 16, if f is equal to sine of e to the negative x, then f prime is, this is a special rule. We have the product rule, the quotient rule, and then we have this special rule. We have the chain rule. Oh my god. All right, so that is derivative of the inside times derivative of the outside, which is going to be negative e to the negative x times cosine e to the negative x. All right, gotta go find it. That is e. I have confirmed. I stopped using different colors, so I'll go ahead and mark all of those. All right, we'll do another page in a second. Okay, so for problems like 17, we are given a function f. F of x is concave down, but increasing. Getting these allows us to analyze stuff for our first and second derivative. So f of 1 is equal to 0. F prime of 1, if f is increasing, is greater than 0. And since it's concave down, f double prime of 1 is going to be less than 0. So now we just have to arrange these in the correct order, which is D, because it's going to be our smallest is our second derivative, our middle is our function, and our first derivative is our greatest. All right, 18. With 18, an equation of the line tangent to the graph of y equals x plus cosine of x at the point is, so we need our slope, which is going to be f at 0, f prime at 0, pardon me, where f of x is equal to y. And then we need some value which we'll solve for. So this is going to be 1 minus sine of 0. Taking the derivative here, don't forget that the derivative of cosine is negative sine. Is that true? Yes. Okay. Which means we have 1 as our slope. That automatically rules out A and E. Don't do extra work if you don't have to, so check yourself each step if you can rule things out. Now, y equals x plus b, we're given this point here. So 1 equals b when I plug everything in. So we should end up with our answer being b. All right, for 19, we are here. For 19, can you see that? Cool. If we have our second derivative, then the graph of x has inflection points when x equals. So we know that there's a 0 at 0, a 0 at -1, and a 0 at 2. When we are looking at these points, we need to evaluate whether or not they change sign. So we can look at the degree on that 0. Since we have this squared part here, that's not going to change sign. We're just going to touch the graph there. Each of these are to the first power, so both of those are going to change sign for us. So for 19, our answer is 0 and -1, or -1 and 0 only. Notice that they have every possible 0 there, so again, it's best to just answer this question without considering the fact that you would have the multiple choice, and then look for your answer that you found there. All right, so for 20, we know what this graph looks like. We know that we have a parabolic thing here, so we need to think about where it's equal to 0. If we had a situation where we had something like a cubic where the positive and negative areas would cancel each other out, that might be something to consider, but this goes back to something we covered in the last video where we were talking about anything from one number to another, as long as, or anything from that number to itself is always going to be 0 because we're adding up nothing. So A is our answer here. All right, now 21. If your derivative is ky and k is non-zero constant, then y could be, so let's do this here, dy dt equals ky. I'm going to solve by splitting and integrating on both sides, so I'm going to divide by y, multiply by dt, divide by y, multiply by dt. I now have dy over y is equal to k dt. I'm going to integrate both sides and continue that down here. I have natural log of y equals kt plus some c. Now I want to solve for y, so I'm going to undo each of these by applying e to each side. So that gives me y equals e to the kt plus c, or e to the kt times e to the c. All right, what that's telling me is I have some constant in front of my e to the kt. So I'm looking for things that have a constant multiplied, and 21 for b, or for 21, b is the only answer. Sorry, that was weirdly phrased, because it's the only one with a constant and it does not include a y. Okay, so this function is given as a quartic function. Which of the following intervals is f increasing? So this is still a non-calculator problem. This is probably not something you'd see on the AP this year because it requires a little bit more algebra than current APs, but let's take a look. To know if something is increasing, that means that f of x is greater than 0. What are you doing? What are you doing, kitten? All right. So let's take the derivative. F prime of x is equal to 4x cubed plus 2x. We want to set this equal to 0 and figure out what values we're looking at. So I can factor that out. I have 4x squared plus 2 equals 0. So we have x equals 0, or well, x equals 0, because if we solved here, we'd have something complex. Okay, so now I'm going to do a sign chart. When x is 0, f of x, is that going to be positive or negative? Plug in 0, or f of x is going to be, let's plug in -1. it's going to be negative, and then let's plug in 1. That's going to be positive. So it's on the value 0 to infinity. The reason I didn't solve out for this is because I know it's going to be complex because this is positive. Don't do more work than you have to. All right, let's do another problem. All right, the graph of f is shown in the figure above. Which of the following could be the derivative of f? So when we're thinking about how to translate a function to its derivative, here are your options. I'm going to go back to our original graph. We know that there needs to be a 0 here, so we need to be crossing the x-axis at that point. Let's go and rule things out based on that. So we are crossing the x-axis here in E and C and A, but in B and D, we're done. So now this is decreasing. I'm going to go back to our graph. This is decreasing, so f prime is less than 0 here. And this is increasing, so f prime is greater than 0 here. Now I need to find a graph where f prime is negative and positive. So we have the opposite here. It's positive on the other side of our 0 and negative here, so I can rule out C and E. Now, when it's between A and E, I have it between something that looks kind of like a sine wave and something that's linear. Because of these little tail guys here, if those were to continue the pattern, we might see a sine curve, or we could see something completely different. But it's definitely not going to be a quadratic function, so we're not looking at a parabola. So we can rule out E because we know it's not going to be linear, which means A has to be our answer.